So this question says that what is the minimum velocity required to move this bucket such that the water does not fall down, assuming the mass of the bucket and the water together is capital M. So at this point, I know that the free body diagram, if I want to draw just next to it, it will be the weight acting downward, right? And I need to give the minimum velocity. For minimum velocity, whatever the tension, this tension will be almost equals to zero because I need to find out the minimum velocity only. So I can simply say that the weight is nothing but the centripetal force. And we know that the whatever the net force is acting towards the center, that will be considered as the centripetal force. So in this case, in order to make the complete vertical circular motion, the centripetal force must be greater than or equals to the weight, which is mg. And centripetal force is what? M is capital M.
Here, did you put weight plus tension is equal to zero?
No, no, no. The
What
only
does that say?
only tension will be equals to zero because we need
Oh,
to find out minimum velocity.
okay.
So the centripetal force is capital M V square over R is greater than equals to M times G. M and this M gets cancelled. So rearranging this equal, V should be greater than or equals to under root of G times R. One important point to be noted here, guys, is that this velocity, or you can say in such situation, the velocity is the V, that is your velocity, is independent on the mass of the object, mass m of the object. It means that whether the object has 1 kg or whether the object has 2 kg, if you are moving that in the same vertical motion with the same radius, same velocity is required, whether it is 1 kg or 2 kg, because it is independent on the mass of the object. So whenever the question asks for the number of revolution per minute, they are basically asking us the frequency, but frequency is always in per second. So once we got in per second, we can directly convert into per minute dividing by 60. So how we can do acceleration is given to us, which is the centripetal acceleration, which is v square over r. Acceleration is 5g, we can take g as 10, so it is 50. And then v is what? 2 pi r by t whole square divided by r. That again, or you can directly use from data booklet 4 pi r square, 4 pi square r over t square. So 1 over t square is frequency. We know this 1 over t is frequency. So 4 pi square r frequency square. So from here we can simply say that frequency will be equals to 50 divided by 4 pi square times r, which is 10, and take a under root. Once you solve this, you will get this as 0.356 per second. Okay, now this is for per second. If I want to do it per minute, I need to multiply this with for per minute. I need to do this by 60. So frequency will be 0.356 times 60, because in 1 second this much revolution are taking. So in 60 second, that is 1 minute. The maximum will be, so how much you will get? Solve this. 0.356 times 60 is 21.36. So you can simply say 21 is the complete number of revolutions. So 21 revolution per minute. So there is a horizontal disk of radius r about a vertical axis through its center. This is the vertical axis and this is rotating. P and Q are 2 points on the disk. Q is on the circumference, where P is at a distance of r by 2. We need to find out the ratios of angular velocity of P by Q, linear velocity P by Q, and centripetal acceleration, the ratios. So the omega is what, guys? Omega we defined, if you remember from part A, omega is angular velocity, which is angular displacement divided by time. So you tell me simply, let us say this point moves from here to here. This point will also move from here to here because they are on the same disk. So they will cover the same angle in same interval of time. So
Yeah.
similarly, omega is what? 2 pi by t. So whether it is P or whether it is Q, that will be the same, right? So the ratio of omega P over omega Q will always be 1 because they will cover equal angle in equal interval of time. That is how we define angular velocity. So the ratio for this will be 1. Now they are asking for linear velocity. We know that Vp over Vq is omega times r, and this is omega times r. We know that omega p and omega q are the same, so it is directly depending on the radius. And we know that at p the radius is r by 2 and at q the radius is r. So you simply this r and this r gets cancelled, so it is 1 is to 2. That is 1 by 2. So the ratio is 1 by 2, like this. And then they are asking us to find out the acceleration. Centripetal acceleration is what? In terms of omega square r. This is also omega square r. So omega of p and q is the same. We already find out above. So this and this will get cancelled. Again, this is r by 2 and this is r. So it is also 1 by 2. That's it. So always remember, the more the farther point from the center, more will be its linear velocity. This is a good one. Draw a free body diagram first. Read the question carefully. So the part A was quite easy. So they are asking us to find out the tension in the string. A body of mass is tied to a string and rotate horizontally. So when it is rotating horizontally on a frictionless table, we know that the tension is nothing but the only force acting. So tension is ma. M is given to us as 1, and isolation will be v square over r. So 2 square over r is 0.4. Once you solve this, it will be 16 by zero point 0.4, which is 10 meter per second square. So, oh, sorry, you can simply say 10 Newton because we are finding out tension, not acceleration. And the B part is when the string breaks the tension. So tension now is 20 Newton. We need to find out what will be its velocity. So 20 is equals to 1 times V square by R. R is still the same, 0.4. You solve this, you will get V something around 2.83 meter per second. And in the C part, the breaking tension of the string is 20 Newton. But if you want the mass to rotate at 4 meter per second, which is greater than the velocity that we figured out above. Determine the shortest length. So for that, we need to reduce the length of the string. So what should be the shortest length that can be used so that we have the velocity? Now we need to find out R. So tension is again 20 Newton, mass is 1, V is this time is 4 square divided by R. We need to find out R. So solve it, you will get R as 16 by 20, which is nothing but 0.8 meter. So the length needs to be 0.8 meters. That is how the length needs to be reduced. Obviously, if you want to increase the speed, you have to increase the R. So initially it was 0.4. Now I want the speed to be 4, so I have to increase the radius. Okay, so the question says that aeroplane is traveling at a speed of 180 meter per second along a horizontal circle making an angle of 35 degree to the horizontal. There is a lift force L is acting in the direction shown. We need to find out the radius of the circle in which it will move. So the question says that this is my plane, let us say, and this is making a horizontal circle like this, like so. So the lift force is acting perpendicular to it. Now, what I need to do first is I need to see how the horizontal circle is and what's my centripetal force. Always remember the question whenever they ask you about circular motion, the first thing we need to find out is the force that is acting towards the center. So let me draw a diagram that will make our work easy. Let us say this is my circular motion in which it is moving. Try to imagine it in 3D, okay? This is the front part and this is the back part. So let us say the plane is at any one point during this curve. This is the radius. This is my plane and this is the radius r. This is what I need to find. Now, if I want to draw the free body diagram at this point, so try to imagine one thing, the L is acting in this direction, which is perpendicular to the plane, and this is given to us as 35 degree. Now, if you look here, can I say that the force, the component of this force acting towards the center will be the centripetal force at this is in this direction, so let us assume this part is somewhat here, so it will make us our work easy, and it is rotating like this. So L is acting in this direction. There is a component of L which is the centripetal force. So if this is L, this is 35. So which will be, what will be, this angle will also be 35, and this is whole 90 degrees, so this will be 55. So if this is L, so this will be L cosine theta, and this will be L sine theta, sine 55. And there is a weight also acting downward, which is balancing the vertical component of the lift because it is moving in horizontal circle. So I can, from this diagram, I can simply say L sine 55 is equals to the weight of the airplane, which is, let us say, mg. This is my equation 1. And the another equation is L cosine theta is equals to the centripetal force, which is mv square by r. Now, in the question, we are given with the speed and we don't have the masses. And we don't have the lift force also. So the best way to eliminate L and M in the same step is to divide equation 1 by equation 2. So what I can say is dividing equation 1 by equation 2. So this will just, let me just copy it down. So this will be like this, and then if I just divide it, the L and L get cancelled, M and M gets cancelled, and this theta is 55. So sine 55 over cos 55, can I say tan 55? And this will be equals to G divided by V square over R. That will go to the numerator, and from here I can say R is equals to tan 55 times V square divided by G. So once you plug in the values, you will almost get 4.7 kilometer or 4,700 meter, roughly in two significant figure. So that's the answer.